This video is to go over lesson 2.17 homework packet 2D. Number 12, which of the following figures appear to be kites? Explain. So I'm just going to explain the definition of kite. The definition of kite is you have one pair of adjacent sides which are congruent, like that. And then another set of adjacent sides must be congruent, like that. That's the kite. Which one, A through G on that piece of paper, fits that definition? Problem 13 to 17. Complete each sentence with always, sometimes, or never to make the statement true. Number 13 says the sum of measures of the angles of a kite is always, sometimes, or never 360 degrees. Which one is that? Which one makes sense to you? And so that's pretty much what you have to do for number 13 through 17. So in math, always means 100% true. Never means 100% false. And sometimes means somewhere in between. So remember that the way we use these language in mathematics, it might be a little different from the way you use in daily life. Number 18, which of the following statement is always true? So this is the multiple choice. Number 1 says a kite has at least one pair of congruent adjacent sides. 2 says a kite has at least one pair of congruent opposite sides. And then 3 is the diagonals of isosceles trapezoids are congruent. So you might want to draw, these are the kites. And trapezoid is you have exactly one parallel sides. So think about this diagram and definition. What can you say about the angles? What can you say about the segments? And choose the correct answers. Number 19, prove that the symmetry diagonal of a kite bisects two angles of the kite. Let's see if this is true. So we have a kite, we have that, and then diagonal actually cuts that this way so that you have two congruent angles. So it says the symmetry. So this is the symmetry diagonal. So this is the symmetry line that gives you, the two congruent sides. And it says you got to prove that is actually bisects two angles. So you got to prove that this angle is congruent to this angle and this angle is congruent to this angle. So if you could prove this triangle is congruent to this triangle, now you can say these are congruent and these are congruent by CP/CPC. And that's 19. Number 20 will be you're going to look at the same quadrilateral, which is the kite, and then you got to prove that the diagonal cuts 90 degrees. So if you can prove this for this problem, if you can prove this triangle is congruent to this triangle, or maybe this triangle is congruent to this triangle, then you can say these two angles are congruent, or these two triangles are congruent. And since these two angles are on a straight line, if these two angles are correct, the only choice we have is these two has to be 90 degrees. So that's something you want to prove first so that you can prove these two angles are congruent. If you can prove these two triangles are congruent, then these two must be 90 degrees. Therefore, it has to be perpendicular. So that's the reasoning, but how can we write that? How can we write the well-written proof? So that's the question for number 20.